Good evening, students. Please turn on your videos. Good evening, Tanmay. No, in the previous class, till where I finished?
Factors affecting ionization energy.
Ionization energy, did I start?
In fact, we are in factors affecting ionization energy.
Okay. Which factor I finished? Recent last factor could you tell?
Atomic radius.
Sorry?
Atomic radius.
Atomic radius. Next side heading, effective nuclear charge. Effective nuclear charge. Effective nuclear charge. Tell me, students, how effective nuclear charge? Video on, yes. Effective nuclear charge. Is it directly proportional to ionization energy or inversely proportional? Yes, that's my correct answer. Effective nuclear charge means nuclear force on valence electrons. If it is more, removal of electron is difficult, so we need to apply more energy. So effective nuclear charge, this is representing with the Z effective, directly proportional to ionization energy. One more thing, half filled end or half filled or completely filled. Configuration, or simply you can write stable configuration. Half filled or completely filled configuration. Students, here nitrogen, oxygen, if you take nitrogen atomic number 7, its electronic configuration is 1s2, 2s2, 2p3. Oxygen atomic number 8, its electronic configuration 1s2, 2s2, 2p4. See, students, here P is the degenerate orbital. Degenerate orbitals, for 3p orbitals are degenerate. Degenerate means they are having same energy. These are having same energy. See here, if the orbitals are having same energy, one electron should be given to each orbital. So only 3 are there, no? 3 electrons we have given to this. Next, if you go to oxygen, 4 electrons are there in P. 1 electron, 1 electron, 1 electron. So the extra electron will be paired up here. Wait, students. Out of these 2 electronic configuration, which electronic configuration is symmetrical or which is stable? And the correct answer. Nitrogen one is stable because half filled or completely filled atomic orbitals are more stable. Half filled or completely filled atomic orbitals are more stable. So why half filled or completely filled atomic orbitals are more stable, students? Because of symmetry. All the atomic orbitals are getting equal number of electrons. If the electrons arranged in symmetrical manner, particular atom will be stable. So compared to here here stability is more. So from this, removal of electron is difficult compared to this one. So in this case, first ionization energy of nitrogen is greater than oxygen. E1 of nitrogen is greater than oxygen. This is one factor. And students, next one, penetration power. Penetration power. Penetration power. Penetration power. What is penetration power? See students, S orbital shape is like this. P orbital shape is like this. D orbital shape is like this. No, it went. Double dumbbell. Actually, F orbital shape is triple dumbbell. It's little complex. No need to write. So among 1, 2, 3, which is having symmetry, students? 1, 2, 3, which is having symmetry? Like this, if I ask, I will get answers this way only. First of all, I have to give what is orbital. Okay, Kripanidhi sent 2, Tanmay sent 3, Sandra sent, Vinith sent 2. First of all, what is orbital, students? What is orbital? No, I don't want this these answers which is symmetrical. I want what is orbital. Do you know? Don't know. Okay. See, students, atom contains shell. Shells contain subshells. Subshells contain orbitals. So finally, orbitals contain electron. So probability of finding electron maximum in which orbitals? That is only orbital definition. Probability of finding electron where it is maximum, that is called orbital. Probability of finding electron is maximum. Where the probability of finding electron is maximum, that is called orbital. That is called orbital. Look at the side, students. So now S orbital shape is spherical. No, Sandra, let me explain. You will come to know. See here, why S orbital shape is spherical? Who check this? S orbital shape is spherical. It is looking like dumbbell. Another one is looking like dumbbell, double dumbbell. It depends on. See here, in S orbital, electrons are probability is symmetrical around the nucleus. Symmetrical around the nucleus. Symmetrical around the nucleus means just this is a nucleus. You just consider electrons are distributed symmetrically around the nucleus means imagine the shape. If it is like this, you can't tell it is symmetrical around the nucleus. If it is like this also, you can't tell. If it is like this also, you can't tell. Only when, or if it is spherical, then only electron distribution is probability of finding electron symmetrical in around the nucleus. Okay, so they imagine like s orbital shape is spherical. It's based on electron probability only. Next, in p orbital, what happens? Some areas probability is maximum. After reaching certain point, it is becoming zero. Again, it is increasing. Again, it is
Sir, your voice is breaking, sir.
increasing again. And after certain extent, it is becoming zero. Come on. Here, first it is maximum. Students. Students, can you hear me now?
Yes, sir.
Yes.
Proper, no? Here in p orbital, what happens? This probability of finding electrons will be like this, like this. After reaching certain point, it becomes zero. Again, it increases. After reaching certain point, it becomes zero. Then they consider like this. So when if, the shape of p orbital is like dumbbell, then only condition will be satisfied. Otherwise, okay. This is called nodal point. That is called nodal point. Nodal point means where the probability of finding electron is zero. So in this way, they decided the shape of p orbital. So okay, that is separate story. Now, probability of finding electron is symmetrical in which subshell students? In which orbital students? S orbital. Here it is not symmetrical. Here it is maximum. Here it is zero. Here it is zero. Here it is maximum. So it is not symmetrical. Electron distribution is not uniform. Somewhere it is becoming zero. Somewhere it is becoming maximum. But in case of s orbital, electron probability is same in all the directions. So among all the orbital subshells S, P, D, F, which is symmetrical, students? S orbital is symmetrical. Symmetrical means you don't decide by seeing the shape. With respect to electron density, you have to see the symmetry. That's why you couldn't answer this question. My question, first, before asking this question, I should have explained this. Now, did you understand, students? With respect to probability, find out the symmetry. Okay. If the probability of finding electron is symmetrical, that orbital will be close to the nucleus, closely penetrate to the. Okay, this one is closely penetrate to the nucleus, closely penetrate to the nucleus. Okay, this is called penetration power. It's called penetration power. So now, penetration power order is S is greater than P, P is greater than D, D is greater than F. So removal of electron from S orbital is difficult compared to P orbital. So S orbital needs more ionization energy compared to P orbital. Here also I will give one example so that you can understand better. Beryllium, another one is boron. Beryllium and boron. Beryllium atomic number is 4. Boron atomic number is 5. Electronic configuration is 1s2, 2s2. Oh, sorry, 2s2 only. Here, boron electron configuration is 1s2, 2s2, 2p1. Observe students, if I want to remove electron here, from which orbital I have to remove? S. Here, p. So in which case, we need to apply more energy? Beryllium or boron? Beryllium or boron? Sandra, correct answer. Removal of s electron is difficult, I said. Yeah. Then my Shraddha, na? Yeah, Shraddha. Dhanush, correct answer. Then my correct answer. Beryllium is because we are removing electron from S. S is closely penetrate to the nucleus. Closely penetrate to the nucleus compared to P. So beryllium, ionization energy of beryllium is greater than boron. This is one more fact. Okay, these are the factors affecting ionization energy. Next side heading, variation of ionization energy in a period and group. Variation of ionization energy in a period. Tell me students, in a period from left to right, ionization energy increases or decreases?
Sir, increases.
Left to right, first check atomic radius, how it is. Ionization energy from left to right, increase or decrease? Nishal, correct answer. Ionization energy, I am asking. Sandra. Vineet, ionization energy. Ionization energy from left to right in a period. First tell me atomic radius, is it increasing or decreasing from left to right?
Decreasing.
Atomic radius decreases. If atomic radius decreases, ionization energy increases or decreases? So I gave factors in last class. Factors affecting ionization energy first. Vineet, correct answer. Adarsh, correct answer. Dhanush, correct answer. See, students, from left to right, atomic radius decreases. Left to right, atomic radius decreases. Just imagine. Removal of electron from this, removal of electron from this. Which is difficult? This one is difficult, last one. Because if size is less, nuclear force of attraction will be more on valence electron. The removal of electron is difficult. Understood? So from left to right, generally you put none before that. Generally ionization energy increases from left to right. Generally ionization energy increase from left to right because atomic radius decreases. Atomic radius decreases, so ionization energy increases. Decreases. Now I'll take one period, second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. If you take this one, lithium to beryllium as it is, it increases, but beryllium to boron, it decreases. You know the reason also. So I are given in penetration power. Next, this one as it is, But compared to nitrogen, compared to oxygen, nitrogen ionization energy is more. Follows as it is. Star mark you put wherever you got exception. Here, what is the reason? Penetration power. 2p1. Here 1s2, 2s2, 2p3 configuration, half filled. Here no half filled configuration. These are the exceptions. They are giving this sequence, they are giving students. With reasons, if you prepare now, it's not difficult to remember. Done, students? Next, in a group. In a group. In a group. In a group, from top to bottom, ionization energy decreases. Ionization energy decreases since atomic radius increases. Since atomic radius increases. Next, applications of ionization energy. First one, metallic, we can find out metallic and non-metallic properties. Metallic and non-metallic properties. See students here, elements with low ionization energies. Elements with low ionization energies. Low ionization energies. Acts as metals or non-metal, students? Elements with low ionization energies acts as metals or non-metals. Low ionization energy means they readily loses electrons. Readily loses electron means their electropositivity character is more. Okay, so electropositive elements are metals. Very good. Next, high ionization energies. Acts as non-metals. Metalloids we can't explain because those exhibit both characters. No, those are in between. Next side heading, electron affinity, and some other applications are there now. Don't want, only it became a little more. Next one, electron affinity. Electron affinity. Do you know, students, what is electron affinity? Electron affinity.
Sir,
Emma,
sir, in the before slide, I left something to write. I was just reading. Yes. Thank you, sir.
Dhanush, energy released, you told. Okay, no problem. You have idea. Even Sandra also. Very good. See, students, so here, why energy is releasing? Anyone, can you tell? You told energy released. The energy released when we add electron to the neutral atom. Why energy is releasing while adding electron? Anyone, can you tell? Low energy. Okay, that is while forming bond. Okay, now I will tell. Turn on your videos, students. Turn on your videos so that I'll get like class feeling. See, students, here electrons are present in shells having negative charge. Now, what I am going to add, that electron also having negative charge. Like charges repel each other. Like charges repel each other. When we add electron here, some repulsions occur between this electron and this electron. In that moment, during the repulsions, atom lose energy. Understood? When we add electron, while adding electrons present in atom and is adding electron is this additional electron. Some repulsions, they oppose the addition of electron. In that moment, some energy will be released. That energy is called electron affinity. Right now, amount of energy released. Amount of energy released when an electron is. Amount of energy released when an electron is added to the. When an electron is added to the outermost shell of energy released when an electron is added to the outermost shell of added to the outermost shell of isolated outermost shell of isolated gaseous atom. Now, electron affinity, is it exothermic or endothermic process, students? Danish, correct answer. Tanmay, correct answer. It is exothermic process. Energy is releasing, right? So it is a exothermic process. But EA2, EA3, so only EA1 is exothermic. Rest all are endothermic process. Reason is, first of all, they are resisting the addition of electron. Once somehow we added one electron. Once after getting negative charge, repulsions will become more because now atom is in complete negative atmosphere. Again, you are adding one more electron. That time we have to apply energy. We have to apply energy to add electron. So it is endothermic process. Hope you understood, students. EA2, EA3 are endothermic process. Sandra, nothing is there. Here, first of all, here repulsion, first case repulsions are more. During that time, atom lose some energy. Atom lose some energy. So that is exothermic. So somehow we added EA2 means addition of second electron. Already you added one electron, so that you need negative ion formed. For that again you are adding one more electron. See students, now atom is in negative atmosphere. Again you are adding one more electron. That time atom will not accept electron. For the somehow you want to add electron. So that time you need to apply energy to overcome the repulsions. So second electron affinity and addition of third electron is still you need more energy to add. So those are all endothermic process. Only addition of first electron is exothermic. Addition of second, third electrons continues. Those are endothermic process. We are applying energy to add electron. Sandra got it. Okay. So next, variation of side heading. Variation of variation of electron affinity in a period. Variation of electron affinity in a period. Yesterday I was in class teaching. Kripani, you are in the class only now?
Yes, sir. No, sir, it was about the yesterday. It unexpectedly turned off. Then I couldn't join the class. I believe, I don't know.
High school office people are there, no, in charges. You have to.
But they were not taking the phones. I don't know. I called some ma'am, the main in charge, I believe.
Don't know, mom. About high school, I don't know. College, I can tell. Just ask other lecturers like Vinith sir and all. If you ask, they will tell you.
Yesterday it
Sandra,
was
while
maths
explain
class.
maths class.
Sorry
That's
to
what they
interrupt you,
will
sir.
tell. Hmm. Other teachers they may tell, because I am taking rarely. High school class I am taking rarely. About college I know whom to contact, and here I don't know. So if I give wrong means contact, that will be a problem again for me and for you also. In a period, from left to Sandra, here it will cover factors separately, not required. Here while explaining variation in period and group only, I can cover. In a period, electron affinity, you just think and tell me electron affinity increase or decrease across the period. So while explaining, while giving answer, keep this one atomic radius in mind. How electron affinity and atomic radius related? Yes, already some students they have given answer. Nishal, Vineet, Tanmay, correct answer. Electron affinities, and now factors you are getting. Electron affinity is inversely proportional to atomic radius. As atomic radius is less, uh, nuclear power will be more, so electrons will be easily. We can add electrons easily. Okay, electron affinity is inversely proportional to atomic radius. There are some counter factors also that I will explain while explaining exceptions. So now in a period from left to right, now in a period from left to right, electron affinity increases. Reason what to write? Since atomic radius decreases. Atomic radius decrease, electron affinity increase. But noble gases are having electron affinity 0 right now. Noble gases electron affinity of noble gases, electron affinity of noble gases is electron affinities of noble gases approximately equal to 0, because already they have stable electronic configuration. They are not ready to lose electron, they are not ready to gain electron. In that case, if they do not accept electron, if they are not ready to gain electron, energy won't release, so electron affinity is equal to 0. Okay. Next one, in a group, in a group, electron affinity decreases because size increases. Generally, here also you put generally. Electron affinity decreases down the group. Here one exception is there, students, and it is important also. Fluorine, I'll go to next slide. Copy it, students, first. Then, students, I'll take one group: fluorine, chlorine, bromine, iodine. You take, as you told, electron affinity decreases down the group, isn't it? But there is one exception here. It should be like this, but chlorine is having more electron affinity than afterwards. It follows as it is ordered. Not only in this group, every second element in the group, in p block elements, every second element in the group has more electron affinity than first element. Simple one conclusion. I'll give the reason now. Generally, what we think, chlorine is more electronegative. Chlorine can accept electrons more effectively than chlorine, so more amount of energy will be released. Electronegativity is different, electron affinity is different. Understood, students? Most of the students have are having this doubt. What is the difference between electronegativity and electron affinity? Electronegativity means just a tendency. It's a tendency of accepting electrons. But electron affinity is after adding the electrons, how much amount of energy released, that is nothing but electron affinity. Tendency is different, energy released is different here. Why? Here tendency is more, but electron affinity is less. Here electron affinity is more, I will tell you. Fluorine, if you take fluorine atomic number 9, its electronic configuration is 1s2, 2s2, 2p5, 2s2, 2p5. In fluorine, you can add only one electron because in second shell only two subshells are there, 2s, 2p. Okay, one if you add one more electron over, you can't add one more electron. So much tendency is there, but only we can add only one electron. In that case, some amount of energy only release. But in case of chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. In third shell, there is one empty orbital, that is d orbital. D starts from third shell. See here, what you know? Here 1 electron we can add extra. Here 10 electrons we can add extra. Because of this empty d orbital, empty d orbitals. 5 d orbitals are there now. In each orbital, 2 electrons. And size difference is not, the difference is not very much. So in case of chlorine, two factors are supporting. In case of fluorine, only one factor is supporting. Nuclear power is more, but there is no accommodation capacity. Here, nuclear power is enough. There is enough nuclear force of attraction. At the same time, it is having enough accommodation capacity. So here, more amount of energy released. Sir, what about bromine? You may get doubt. If you take bromine, see students, 4 shells are there. That time, attracting the power that factor is there, no, that will not support. Because as the size increases, the attracting power decreases. But in case of chlorine, two factors are supporting. Accepting tendency is there, accommodation power is there. It's like, I'll give one general example. I think I had given last class also. One general example. I started one institution. It is small, but it is having very good name. Reputation is there. So many students are trying to join, but accommodation power is less. That capacity is less. The time, though an institution has a very good reputation, I will get less amount only. By one more person started institution like Tanmay. His institution is very big, but no name. In that case, he may not get much amount, isn't it? Accommodation power is there, but attracting capacity is not. By copying both of us, Kripani started one more institution. It is not very big and it is having enough name. So compared to me and compared to Tanmay, he will get more because he has enough accommodation capacity. At the same time, his institution has what a good reputation. Both factors are supporting in this case. In case of Tanmay, institution is big, but reputation is not there. That factor is not supporting. In my case, reputation is there, but accommodation power is not there. Okay. So now Kripani is chlorine. I am fluorine. Tanmay is bromine. Okay. Understood, students? Hope you understood. So that is the reason. Not only in this group, every second element or every third period element in the group has more electron affinity than first element. Afterwards, it follows a regular order. If I take oxygen, sulfur, selenium, tellurium, polonium. Polonium don't want radioactive element. So here, second element is sulfur. So afterwards, it follows regular order. 16th group. And 15th group, if I take nitrogen, phosphorus, arsenic, antimony, bismuth. So from nitrogen to phosphorus increases, afterwards it decreases. Got it, students? Among the following, which represents correct order? Next side heading, electronegativity. Electronegativity. What is electronegativity, students? We need okay. Next. I'm given different definitions. I'll give my definition. Electronegativity is bonding property. Electronegativity is a bonding property. Suppose here, in case of heteroatomic molecules, one will be more electronegative, one will be more less electronegative. In that case, somewhat electronegative atom trying to attract bond pair of electron. Bond contains 2 electrons. Bond pair of electrons towards itself. Yes, Kripanidhi, it's correct definition, perfect definition. Tendency of attracting bond pair or shared pair of electrons towards itself. Towards itself. Tendency of attracting bond pair of electrons or shared pair of electrons towards itself. Towards itself is called electronegativity. Tendency of attracting bond pair of electrons or shared pair of electrons is called electronegativity. Now, it is a bonding property. Remaining all properties are isolated properties. Isolated property means non-bonding atom, single unit like atomic properties. This is bonding. For molecule, we will find this property. Understood? After bonding only, we can explain this property. Some students they send definition like tendency of attracting electrons. That is not correct definition, students. Tendency of attracting bond pair of electrons or shared pair of electrons towards itself. Once I'll off the video, check students. If the voice is not proper, you tell me, I'll change the network. Actually, it is not network problem. Here some system updation is pending. Because of that, it became slow. Students, can you hear me now?
Yes, sir, you are now on.
Sir,
Kripanidhi, what happened exactly? His voice is breaking or?
No, sir, it was breaking. Now it's fine, sir.
Earlier it was breaking.
Yes, sir.
Okay, ma'am. You tell me, I'll change the network if any problem is there. I'll try other network. Okay, ma'am. Tendency of attracting a bond pair of electrons towards itself is electronegativity. Now, variation of electronegativity in a period. Tell me, students. Is it increase or decrease? Yes, correct answer, students. In a period, electronegativity increases. Increase. Since atomic radius decrease. atomic radius decreases.
Sir,
Tell me.
sir, then electronegativity is also inversely proportional, right?
Yes, yes. Electronegativity is inversely proportional to atomic radius. Right now, in a period from left to right, electronegativity decreases. Electronegativity increases. Since atomic radius decreases. In a group. In a group. Tell me, students, in a group, it decreases. Radius increases. Which group elements are having highest electronegativity, students? From left to right, it increases, right? So, which group elements are having more electronegativities? Tanmay, correct answer. First group elements from left to right, it increases. Beneath left to right increases means first group elements are having less electronegativity. No. 17th group elements. Dhanush, correct answer. 17th group elements are having. 17th group elements are having highest electronegativities. In that 17th group, which element has highest electronegativity? From top to bottom, it decreases. So first element has more electronegativity. Okay. So now highest electronegativity element is fluorine. Highest electronegative element is fluorine. Fluorine is the highest electronegative element. Next, one more thing. Highest electronegative elements are highly reactive. Highly electropositive elements are highly reactive. So, according to that statement, 17th group elements are highly reactive. Right now, 17th group elements are highly reactive. If you want, write this point also. Highly electronegative elements are highly reactive. So 17th group elements are more reactive. Next one. Electropositivity. Electropositivity. What is electropositivity, students? Tendency of losing electrons. Tendency of losing electrons is called electropositivity. Right, students? electrons is called electropositivity. Variation. Variation of electropositivity. Variation of electropositivity in a group. Sorry, in a period. In a period, what happens, students?
Sir. Sir,
Tell me now.
in a period, electropositivity decreases from left to right.
In a period, decrease. Yes. Decrease from left to right. Electropositivity decrease from left to right. Since atomic radius decrease. Same reason. Atomic radius decrease. So this electropositivity is nothing but metallic property. Electropositivity is also metallic property. But metallic property. So from left to right, metallic nature decreases, non-metallic nature increases. Right, Nana? Is also called metallic property. From left to right, metallic property decreases, non-metallic property increases in a period. Next, in a group. In a group, from top to bottom,
Increases, sir.
increase. Very good. Increase. Since atomic radius increases. Since atomic radius increases. Atomic radius increases. So if you see, first group elements are highly electropositive. Let's suppose lithium, sodium, potassium, rubidium, cesium. These are highly electropositive. So these are highly reactive. Highly electropositive elements. Highly electropositive. Again, from top to bottom it increases, right? So, which is the highest electropositive element in the periodic table? Cesium. Yes. Highest electropositive element is cesium in the periodic table. And reactivity also more. I told you, no, these are highly electropositive elements, so they are highly reactive. You know, electronegativity time, when I was explaining electronegativity, I told you, highly electropositive elements are highly reactive. Highly electronegative elements are also highly reactive. Highly electropositive, highly reactive. So in periodic table, first group elements and 17th group elements are highly reactive. Next, done students? Next one. Nature of oxides. How to decide which is more metallic and non-metallic properties? Again, I am not discussing because electropositivity is nothing but metallic property. Electronegativity is nothing but non-metallic property. So same trend is same. Now, nature of oxides. After this topic, I will do breakout room, students. I think they uploaded. So, nature of oxides. See, students, sodium, magnesium, aluminium, silicon, phosphorus, chlorine. So, which is more metallic? You tell me, students. Which is more metallic in the given? These are all third period elements. This is one period. So, very good. Then my correct answer. Sodium is more metallic. Sodium is more metallic means now it's metal. One point I want to give. Metallic oxides are basic in nature. Metallic oxides are basic in nature. More metallic means more basic. More metallic means more basic. As you told, sodium is more metallic. So this will form oxide of the type Na2O. This will form MgO, Al2O3, SiO2, P2O5, Cl2O7. So according to their valencies, they form the different types of oxides. In that, which is more acidic, which is more basic? This type of questions are very familiar, students. So Na2O is more basic since the central atom is more metallic. Right now, metallic oxides are acidic, basic in nature. Since they on hydrolysis they produce respective bases. Non-metallic oxides are acidic. Acidic. So here to here, basic nature decreases. If you want to write acidic nature, increases. One minute, students. I will ask them whether they uploaded or not. But In Schoology, you have to check, students. After break, I'll do the breakout rooms. Then you go to school, not school, yeah, workbook. Okay, non-metallic nature increases. And suppose if the same central atom forms different oxides, suppose phosphorus can form different types of oxides, P2O3, P2O4, P2O5. Which is more acidic? Anyone, can you tell, students? You no need to type everything. 1, 2, 3. I'm giving just number if you send enough. Out of 1, 2, 3, which is more acidic? Kripani, the correct answer. No. P2O5 is more acidic because here oxidation state is more. When once oxidation state is more, positive character tendency of attracting electrons also will become more. Otherwise, simple thing I will tell, number of oxidants increases, acidic character increases. In case if central atom is same, number of oxidants increases, acidic character increases. Lewis acidic character increases. Acidic strength increases. Copy it. Next one. Okay, ma. I'll do the breakout rooms. With whatever the questions, answers you know that you do. Wherever you get doubt, you can ask. Otherwise, in next also we can discuss.
Sir, should we open the workbook now through the PDF?
Yeah. You have to open and try to solve. Now, while assigning the rooms, so please accept students.
Sir,
Tell me, Kripanin. What happened?
sir, I have some doubts in 14th one.
I'll do one thing. Next class I will explain because workbook I will bring. Okay, whatever you know, try to solve, student. For that reason only I close the rooms now.
Yes, sir.
By next class, try to solve maximum questions by referring the books. So whatever the questions answers you don't know, that we will discuss in the next class, so that we can finish fast and you will get the confidence also. Okay, students, thank you. Is it
Thank
raining
you,
now?
sir.
Yes, sir.
Is it raining in Mangalore?
No, sir.
No. Okay. Thank you,
I will-
students. Bye bye.